Hey guys, welcome to my next video on cycloidal drives. Like the harmonic drive in my last video, this gearbox also incorporates a wave generator, but uses it in a different way. Here you can see the input is driven by the stepper motor, which turns an offset drive shaft to rotate two discs around the inside of the housing. The two discs are offset by 180 degrees to balance the gearbox. If there was only one disc, the gearbox would work the same way, but in a realistic full metal situation, there would be a lot of vibration. With the extra disc there, offset 180 degrees, the vibrations coming from both discs partially cancel each other out. The total gear ratio of this gearbox that I designed is 15:1, and it turns opposite that of the input. This can be calculated by the amount of rolls or pins in the housing minus 1. The eccentricity is the offset of the center drive shaft, which generates the wave acted upon the discs. In this case, the eccentricity is 2 mm. A greater eccentricity is more difficult to make compact, but reduces the odds of the disc slipping. The pins are 8 mm diameter minus some backlash needed for printing, and the pins are positioned around a 65 mm diameter. The discs can be created using calculations based on the eccentricity, pin diameter, and pin position diameter. I won't go through that in this video since it would make this much longer and more boring. Everything was made of PETG on my Ender 5S1. I built the output housing by creating two halves and holding them together using screws that also hold the bearings used as load pins. The discs are stacked on top of each other through bearings and the drive shaft and spin around the pins on the outside. The load pins are inserted into the 4 holes in the discs. When the motor is spinning, you can see the discs spinning around the pins slower than the motor is spinning, creating more torque. This gets transferred to the load pins, which turn the output. This gearbox did take quite a bit longer to design in terms of figuring out how it works and how the discs are made properly, but I am very happy with the results. There is basically no backlash at all, although it may be a little bit tight, which is why this gearbox is quite a bit louder than the harmonic drive. The harmonic drive used a TPU gear, which would have helped dampen the noise quite a bit. Thanks for watching, and feel free to check out my channel for similar videos.